So next module is audio video compression techniques. So here we are going to discuss about the basic principles of audio video compression technique and DPCM. So what is compression is nothing but reduction of volume of the original information. Why we want to go for a compression in the sense, suppose the in order to why we are going for the compression in the sense, suppose the signal bandwidth is more than the channel bandwidth, in the sense we cannot able to transmit. Second thing, in order to store the information which requires more amount of memory space. So for both the things we are going with the compression technique. In the compression, in the sense, two types of compression. One is lossy compression, another one is a lossless compression. Lossy compression in the sense, the amount of volume of information can be reduced with the loss. Loss in the sense, unwanted signals which is not required for the transmission, that can be eliminated, that can be eradicated. That is nothing but the lossy compression. Example, audio video are coming under the lossy compression techniques. And lossless compression techniques, in the sense, the signal whichever have the original information that cannot be changed after compression, also the same information can be reconstructed in the decompression. That is nothing but lossless compression. For example, text, you are sending some information, it's a large volume of information that you are compressing. In the reception side, the same has to be reconstructed. If anything is changes, then error will be created. Same like a picture image also. So this is coming under the picture, and the text are coming under lossless transmission. And lossy compression, in the sense, audio and video are coming under the lossy compressions. So for both audio and video are continuously varying signal. It is an analog signal. After digitization principle, it has to be comprises continuous streams digital values, each value representing the amplitude of the sample in a particular analog signal. So the compression algorithm is related with the digitized audio and video with the different forms of text and images. And digitization audio signals is done using digitization process is called a pulse code modulation. PCM involves the sampling the waveform at a minimum rate and twice of the maximum frequency component, that is, it has to satisfy the Nyquist frequency or Nyquist rate. If the frequency of the bandwidth of the communication channel is used less than the signal, then the sampling rate must be determined. The bandwidth of the communication channel is known as band limited signal. Suppose in case of speech signal, the maximum frequency component is 10 kHz and the minimum sampling rate is 20 kilo samples per second. So sampling rate for audio is 20 kilo samples per second and music is 40 kilo samples per second. The number of bits per sample audio is 16 bits and speech is 12 bits. So stereophonic signal has two channels. The two signals must be digitized, and the bit rate for that particular channel is 240 kbps and 1.28 megabits per second for the stereophonic. It can be achieved in two ways. Either audio signal must be sampled at a lower rate and compression algorithm must be used. Disadvantages, in the sense, the quality of the decoded signal is reduced due to loss of high frequency components, and the fewer bits of the sample results in the introduction to the higher levels of the quantization noise. And this achieve the comparable perception quality to obtain that higher sampling rate but with the reduced bandwidth requirement. So next we are using this DPCM, that is nothing but differential pulse code modulation. So here the range of differences in the amplitude between the successive samples are less than the range of the actual samples. So only the digitized frequency signal is used to encode the waveform. So DPCM encoder and decoder are shown here, which has the band limiting filter, ADC, and then subtractor, and then register and adder circuit will be there. Then it is given to the parallel to serial converter, then network. In the decoder circuit we have a serial to parallel converter, adder, register, DAC, and low pass filter. Here the speech signal will be given. So the band limiting signal filter will limits the signal frequency range. Then it is given to the ADC. ADC will convert the analog signal to digital signal. Then the pulse code modulation will modulated signal will be obtained, that will be given to the subtractor, and part of the DPCM is given to the adder and register. So comparing these to the previous values, the DPCM value will be obtained, that will be given to the serial converter through the network. In the reception side we have a adder circuit and register circuit. So DPCM will be added and register. Again we will get the PCM, then it will be converted into analog, then it is given to the low pass filter in order to filter the original signal. So the previous digitized sample of the analog input signal is stored in the register R, the temporary storage it is, and the difference of the DPCM is computed by subtracting the current content with the R0. For the new digitized sample will be getting the value of the register in the updated thing is added in the current register and computed and again subtracted. So decoder operates by simply adding the difference of the signal and thing will be happened. And here the proportions are used to determine the what is known as predictor coefficient and principles. So in this scheme the different signal is computed by subtracting the varying portion of the last three predicted values. If 3 predictor coefficient as the values of C is equal to 0.5, C2 is equal to C3 is equal to 0.25, the content which is stored in the R1 will be shifted by 1 and register R2 R3 by 2 bits. So the comparison of these two things, so we will get that 0.25. What is the difference between the PCM and DPCM in the sense? In the PCM there is while we are doing for the quantization, so we are getting the after sampling we are getting the discrete values. We have to assign some values in the sense which is very close, both are close in the sense one will be neglected. Suppose one discrete value is 0.25, another discrete value is 0.3, and another discrete value is 0.35. Everything is very close in the sense one will be taken, 0.3 will be taken and 0.4 will be taken, 0.5 will be taken. So 0.25 will be neglected, 0.35 also neglected. But if you talk about the DPCM in the sense, it will compare the previous value and the next value. It takes the difference of that particular value. Suppose at a t1 time interval 0.25 is created. At t2 intervals 0.5 will be generated. At t3 intervals 0.75 will be generated. In the sense the difference of this 0.25, 0.5, 0.75 is nothing but 0.25. So the 0.25 will be generated. So that is nothing but differential pulse code modulation. So 3 shifted values are added together and resulting sum is subtracted from the current values in the encoder, but in the decoder it will be added. So the current control register R1 is transferred to R2 and then that R2 is transferred to R3. So new predicted value is loaded in R1 for the next sample to be produced. So that is the DPCM. And while talking about the ADPCM is nothing but adaptive differential pulse code modulation. So The definition is using varying number of bits for the different signal depending upon the amplitude. The fewer bits are encoded with the smaller difference values for the larger values. So bandwidth will be saved for the quality, audio quality. It is based on the same principle as like a DPCM, but 8 order predictor is used and 6 bits are used for the 32 bits better quality. 5 bits are used for the lower bandwidth if the lower bandwidth is appeared, which provides very better sound quality. And to achieve this ADPCM, we are using a technique called a subband coding. So input speed signal is nearly 50 hertz to 7 kilohertz, and conference applications where we can use this one. And to get a higher signal bandwidth, the sampling audio signal must be passed through the two filters. One is nothing but signal frequency of 50 hertz to 3.5 hertz, another frequency of 3.5 hertz to 7 kilohertz. This is the subband between the two separate channel bandwidth signals. Each subband is sampled and encoded at the rate of upper subband allows 16 ksp's, and two subbands have the different bit rates. The frequency components present at lower subband have the high perceptual with the higher subband. Operating bit rate is 48 kbps, and ADPC, that is adaptive predictive coding, higher levels of the compression at higher levels. The complexity can be obtained by making the predictor. Here, the predictor coefficient is continuously changing. So, here the optimum set of the coefficients are computed, then it is used to predict more accurately. And LPC, in the sense, all previous algorithms are considered. And this type of compressions like adaptive predictive, this one differential PCM is used for the various things. So the input signal is effectively divided into two separate equal bandwidth. So one is a lower subband, another one is a higher subband or upper subband. So each subband is then sampled, encoded, and the sampling rate will be changes for the lower and upper. So the frequency components present in the lower will be having the different perceptual importance than the higher one. After that, the two bits are multiplexed and merged together and transmitted, and at the decoder it will be received and divide them back again with the two separate streams.